This video is going to cover transcriptional regulation in prokaryotes. In prokaryotes, operons are the segments of DNA containing genes controlled by a single promoter, which is a nucleotide sequence that allows genes to be transcribed. An enzyme known as RNA polymerase recognizes this promoter sequence, which allows the initiation of transcription to occur. The genes in an operon can be classified as either regulatory genes or structural genes. Regulatory genes produce molecules that aid in the expression of certain genes, whereas structural genes consist of all other genes that are essential for structural or metabolic components of a cell. The mode of transcriptional regulation that I'll be focusing on is positive inducible. To clarify what this means, positive control is the regulatory mechanism where a regulatory protein, in this case an activator protein, binds to DNA to initiate transcription. This activator protein is coded for by an activator gene. Inducible control describes when a cell that has transcription turned off in normal settings to turn on when a small molecule known as an effector binds to the activator molecule to change its conformational shape. In positive inducible regulation, transcription is normally off, but in the presence of an effector molecule, the activator binds to the promoter region to initiate transcription. To illustrate the process of regulation, I'll be first showing an operon in normal conditions where an activator protein is produced by the activator gene in its conformationally inactive form. When a small effector molecule is present, it binds to the effector protein, the activator protein. Once it binds, it causes a conformational change of the shape of the activator protein. Once this occurs, the activator and substrate complex binds to the activator binding site, located near the promoter region, and increases the affinity of the RNA polymerase to bind to the promoter region, which initiates transcription. This then allows structural genes in the pathway to be transcribed. Without the small effector molecule, transcription cannot occur since the activator molecule needs it to effectively bind to the promoter and bring RNA polymerase to do its job. An analogy of positive inducible regulation is Popeye the Sailor Man. This tough guy is known for his ability to use his strength and intelligence to face seemingly insurmountable obstacles. He frequently gets into conflicts with his nemesis, Pluto. When tasked with defeating Pluto, Popeye relies on spinach to give him large muscles and superhuman strength. In this case, spinach is analogous to a small effector molecule, and Popeye's stomach is analogous to an activator molecule. When spinach enters Popeye's stomach, his arms grow to superhuman size, and Popeye is then able to beat up Pluto. In this case, his arms would represent RNA polymerase, and the act of beating up Pluto would represent transcription. Similarly to positive inducible regulation, where an effector, which is spinach, must bind to an activator molecule, which would be his stomach, in order for RNA polymerase, which would be his arms, to start transcribing DNA, which is beating up Pluto. Without spinach, his arms would be empty, his stomach would be empty, and Popeye would not have the miracle food he needs to grow his large arms and defeat Pluto. This is analogous to a situation where an operon lacks a small effector molecule, and therefore the activator molecule is unable to bind to help initiate transcription.